I'm excited to be here, and it's been great to hear everyone give an introduction to Crossplane. I'm going to spend my time talking about the open application model, which is actually a project independent of Crossplane, but really intended to provide an application model that you can use for Kubernetes, or really honestly could be adaptable to anything you want to do. Let's get into this. All right, so the Open Application Model, or OAM, is an open source project that we announced close to a year ago, actually, and have been working on in collaboration, as was mentioned, with Alibaba and with the Crossplane folks. And I wanted to spend the time today talking about the motivations and the open areas in Kubernetes that we saw that motivated the work. Give you a little bit of a flavor for what it's like, so that the people who are going to come do some demos later have some grounding, and give some brief examples of what it looks like to put one of these applications together. All right. So, Kubernetes. I think of Kubernetes. I've said it before. I think of Kubernetes as an assembly language. That it is a bunch of pieces that are very useful, like just as instructions in an assembly language, or low-level componentry in an operating system. There's a lot of very useful pieces for orchestrating our infrastructure and for describing what we want to have happen in the world. Kelsey talked a lot about that idea of like expressing a declarative config, and then the reconciliation that will take it and turn it into something that is manifested in the world. That's really, really useful. And Kubernetes was designed from the get-go to actually be a very decoupled system. So there's not a lot of containment in the API itself. Namespaces maybe are the most containing thing that exists, but the truth is that a namespace is not really a good descriptor of an application. It's more often used as a RBAC boundary or a scope for RBAC, rather than something that organizes a particular application. And so when we think about developers, and we think about teams, and we think about meeting teams who are building and deploying these applications sort of in their mindset, what you see in Kubernetes, and I think what a lot of people struggle with when they come to Kubernetes, is a lack of an application primitive, right? There's nothing in Kubernetes that you'd hang your hat on and say, that's my app. And so the open application model really attempts to solve this problem. Because I think when we think about it, Kubernetes was built from the bottom up with operators in mind. And so it provides primitives that make sense to operators, but that doesn't make sense necessarily to developers. Right. So if you look at these, I think this just drives this point home. If you look at Kubernetes, you might say, okay, at its simplest, this is what an application might be, right? There's 4 objects involved here in Kubernetes. There's the deployment, which is what most people interact with. There's the replica set, which almost no one knows is actually there, because it's really an implementation detail of the deployment, even though actually it was one of the original its sibling was the replication controller, was one of the original primitives. But at this point, the replica set has basically vanished. It's an implementation detail. And then there's pods, and people don't really think about creating pods. They think about interacting with pods when it comes to debug something, or if you need to whack a pod on the head when it's sick and let a deployment recreate it, or monitor it, or things like that. And then, of course, if you're putting it out and making it available to the internet, maybe you're using a service, or you're using an ingress, which uses a service behind the scenes. But the truth is that though you could think about all these objects as composing a piece of your application, there is no object that represents it, right? There is no object that actually holds all those pieces together. The best that you could hope for is a YAML file that has sort of a bunch of Kubernetes objects smashed together with the three dash syntax separating the objects, or maybe a Helm chart, which again has some degree of representing of the object, but really is a representation of the configuration of all the pieces, and isn't really something that describes the object itself. This is just sort of showing that there is all of the application might be the pieces um, there. But when we look at the pods themselves, um, there is a bunch of pieces even inside of the pod, right? That is not necessarily even the application, right? So if we previously said, hey, the application is the deployment that creates a bunch of pods that uh, you know created the running bits. The truth is that, like, well, but if you had a service mesh running in your cluster, that service mesh actually injected a sidecar that the developer knew nothing about, actually, right? So suddenly, even within one of those objects, it actually gets kind of muddied, right? Because a different team maybe, because the service mesh again is installed at the cluster level, right? And so a different team is actually responsible for that service mesh. And if you're a developer who's not maybe super sophisticated with Kubernetes, you may not even realize that that ambassador got shoved in, right? Or similarly, like you could be injecting, a log saver like Fluentd. I mean, your monitoring team may have set up that log saver. You might not even know it's there. You're like, well, somehow I deployed a Kubernetes and magically something appears in Elasticsearch. Um, but I don't care, right? Like, why should I care about that implementation? And so I think that, even within the confines of um, the basic Kubernetes objects, it turns out that the definition of the application is actually quite fuzzy, right? That there is not a really crisp way of defining the bits that the developer brings to the table and the bits that a different team might bring to the table. And so we need to kind of represent that, because of course, like, if you deploy something into multiple different environments, you may actually be using different monitoring solutions or different service meshes, or any number of different sidecars depending on the details of the system that you're, or the environment that you're deploying into. Um, so when I think back, I think I think the important thing to think about is, like, what were who are the people who are intended to work with Kubernetes? I mentioned a lot about operators, and cluster administrators and application developers, and I think that these are some of the various personas. I've shown this slide before. These are some of the various personas that kind of come together inside of the Kubernetes cluster. And that separation of concerns is actually a really powerful part of what it means to, you know, provide Kubernetes as a service. And so I think that when even within the cluster, these personas come into being, right? There's someone who's managing the cluster for you and adding things like, monitoring and things like that. Even if you use a managed Kubernetes solution like Azure Kubernetes Service or any of the other cloud provided managed Kubernetes, there's still this separation of the application developer and the application developer persona, possibly the application operator, although DevOps would tell you those people are supposed to be the same. But then there's also the cluster operator. Even in a managed Kubernetes, there's someone who's going to come along and install cluster-wide monitoring, cluster-wide intrusion detection, cluster-wide logging, or any other kind of cert management, any other number of these services that are deeply coupled with how your application works, but are really managed by a separate team. Right? And so there is this notion that separating these concerns is a really important problem that Kubernetes isn't really addressing. Right? And that's where the open application model is stepping in to try and provide a solution that allows you to think and express an application and make that be independent than from something like a trait that is required, like a service mesh, or even from a component that's required, like a reliable database, right? Because in many of these environments, as was alluded to earlier, these enterprise environments, you don't get to just kind of spin up a database, like, or any other kind of component. You have to use a blessed version, right? You have to use a blessed configuration. And it makes sense, of course, right? I don't want to have 30,000 different versions of MySQL running around in my environment, because it's a nightmare to patch when the security update comes out. I want one version of MySQL. And the only way that I can achieve that is by saying to the developer, like, hey, you don't get to choose. You just have to use this database component. And again, that's not something you can use policy to enforce something like that. But then you become guess and check, where somebody is like, Well, let me try this MySQL version. Did that pass policy? No. Let me try another MySQL version. Did that pass policy? That's a bad experience, right? You want to provide a component that simply gives someone a compliant database from the get-go. And again, that's what OAM is trying to do. And then finally, like I think we're seeing this explosion of the edge, right? We're seeing this real realization, and I'm going to admit that I was one of these people too who thought, well, you know what, cloud is the eventual goal. Cloud is where everybody's headed. This hybrid thing, like it's a way station on the way to cloud. But I think the reality of the situation that we've realized is that hybrid is the steady state, right? There is no application that doesn't have an edge component, that doesn't have a in cloud component. And so being able to write an application that seamlessly moves from an on-cloud environment to an on-premise environment, or even across cloud environments, is a requirement for many of the, if not all of the applications that we're seeing deployed to our cloud. All right. So this is really what OAM is trying to provide, right? So OAM provides an application model that separates these concerns, can be deployed to any number of different cloud environments, can be deployed to things on the edge like Raspberry Pi, and can be deployed to Kubernetes on premise as well, right? So that we can actually stand a chance of expressing an application. Like you're going to take a really heavy service mesh and run it on a bunch of Raspberry Pis, it's not going to work, right? And so it's important that an application be able to express its dependencies or express the components that it uses and have those components be adapted to the right environment so that in a cloud and hosted environment, I might get a hosted version of MySQL. And in an on-premise environment, I'm going to get a SQL run by my SQL team as a service. And in an edge environment, well, maybe I'm just going to spin up a MySQL container and hope for the best, right? So like there is this notion that I can say, I need a component, but I don't necessarily have the details of how that component is supplied in any particular environment. As was mentioned earlier, this is a collaborative effort. It's been developed in the open on GitHub from the get-go. It's been really great to see Alibaba and Upbound get involved in the project, and Alibaba has been there from the very beginning. And it's really a spec and a API model for trying to solve all of these problems that I described before. It's currently in its second working draft, as was mentioned, and we think that we are slowly converging on something that we can really stand behind and turn into something that can be made generally available to people. And so it's really been great to see the progress there. I wanted to give an example of what this looks like in practice. This is a pretty simple application, and you're actually, I think, going to see a demo of it later on today. But these are all of the pieces that make up this flight tracker sample app. And this sample app is actually up on GitHub if you want to take a look at it. It's got a UI, it's got a bunch of different APIs for flights or earthquakes or weather. It's got a background data API. Everything's persisted to a Postgres database. This is sort of the definition of if I did my whiteboard drawing, which is sort of like the litmus test for what an application is tell that person to go up to a whiteboard and draw their app. That's their application, right? And if I was going to do that on a whiteboard, the picture wouldn't be this pretty, but this is the picture of what that would look like. So let's take a look at how we think about putting this together in OAM. We're going to take those components apart. We're going to have a database component, flights API component, weather API component, UX component, Quakes componentry. And each of those components is really like one of these puzzle pieces. It exists to be used by someone who needs to put it together in their application. So that Postgres component can be used wherever somebody needs a Postgres, for example. So here's an example of what that spec looks like. Obviously, there was a joke made earlier about YAML everywhere, and it's true. There's more YAML here, and it's also structured obviously like a Kubernetes API object. But what you can see here is that this is sort of a meta description. We're defining a workload, which is the type of the component. It's a containerized workload, and then we give the blueprint for that component. So we can actually say, hey, this is what it means to instantiate the database. And these are the containers you need to deploy. These are all the pieces. This is how everything fits together. And with this component, then it's kind of like, a persistent volume claim. I can actually just sort of go out there and say, hey, I want one of those components. I don't have to worry about defining it. I don't have to figure out the best way to deploy one of these databases into my environment, set up backup, set up monitoring. I simply say, hey, I want one of those database thingies, and it pops into existence. And I think this is, again, there was a little bit of discussion in the beginning about the role of abstraction and how, in order to really enable people to build these systems reliably, we have to be building abstractions, right? We can't say to every single developer who needs a database, like, go read up on how to best deploy Postgres, and good luck, right? That's not scalable, and honestly, it's not even useful. Even if you can figure out a really awesome way to run Postgres, that's not a useful use of your time, right? So the history of computer science is a history of building these higher level abstractions, not just because things were hard, but actually because it freed up your mind and it freed up your intellectual engagement to work on more interesting problems that someone hadn't already solved. So we can collaborate around these components, build really awesome ones, and then nobody will ever have to worry about it again. And I think you've already seen this. I mean, you've seen this in the Helm community, and elsewhere, that when you provide opportunities to collaborate, we build really great solutions, and then those solutions simply become the de facto standard. And that's part of what we're trying to do here, but in a way that is more object oriented and more object modeled than Helm might necessarily be. All right. So then once we have all of those components, all of those Lego pieces, if you will, what we're going to be doing is actually taking all those Lego pieces and putting them together into something that's pretty awesome. Um, and so I have to, in full spirit of transparency, I did not build this Lego model. This is some really cool person who built this Lego model. I simply found a picture on the internet. I wish I had enough classic space Lego to build this model. Although I do have that spaceship in the middle. So here's the configuration. This is where we take all those components and we put them together into that awesome model. And what you can see here is there's a component list. I'm going to give a component name, and then I'm going to actually give it some parameters. And so there's actually two components here. There's this tracker, which doesn't have any parameters. So this is how we put the components together. The parameterization here shows like, oh, this is going to be the database secret, the database user for connecting to that database. And so this then becomes that application definition that we mentioned was missing earlier, right? And I'm not going to give a chance to cover it here, but also you can have this notion of binding to traits, where that would be something like providing monitoring or service mesh or those cluster-wide configurations. So the application is a combination of components that it's putting together and traits that supply, those cluster-level capabilities. It's sort of a whirlwind tour of OAM. But I hope that gave you an idea about what we're about. If it sounds interesting to you, or even if you just want to learn a little bit more, stay tuned for some talks from Alibaba and other folks from Microsoft. And also, you can come and get involved in our community calls, or just take a look at the GitHub project that's out there. There's a number of different samples about how to come and try it out and contribute. And thanks very much to the Crossplane community for inviting me and for having me talk.
Thanks for Brandon's high-level overview of OAM, as well as the talking about the relationship between OAM and Kubernetes. So I'm Xiang from Alibaba Cloud. So I'm going to talk more about the OAM model inside Alibaba and how we see the value OAM brings to our ecosystem. So before getting into OAM, first I want to take a look at the infrastructure for application management at Alibaba. So 2 years ago, we started to migrate our in-house built container platform to Kubernetes. And since 2019, we started to move our critical workloads from our on-premise data center to Alibaba Cloud. So by doing that, we were able to gain more computing resource elasticity. At Alibaba, we use Kubernetes as a framework or platform for platform. So we develop our own set of core controllers, schedulers, webhooks, etc. Some of the controllers we build internally are already open sourced as OpenCruise, and we are going to open source more in the incoming months. And today, Alibaba is operating nearly 100 production Kubernetes clusters just for our internal workload. We are operating many more for our public cloud users. And we have clusters in the scale of 10,000 nodes and millions of containers for just one single cluster. And so far, so good. Everything's infrastructure related is kind of consolidated, and it seems to be a pretty consistent across the Alibaba group. However, if we look one layer above, it becomes much messier. So many different units, business units inside Alibaba have built their own application platforms. Some platforms we built before the Kubernetes came along and were directly against the traditional physical machine-based infrastructure layer. And although they are migrating to Kubernetes, from their point of view, the port inside Kubernetes is just a lightweight virtual machine, and all their controlling logic is still out of the scope of Kubernetes. And we also have some platforms built directly on top of Kubernetes. And actually building a platform on Kubernetes is dramatically simpler compared to the legacy counterparties because Kubernetes did all the heavy lifting. The problem is that they all developed their own CRs and nothing is really reusable. And from the developer's point of view, the only similarity is the YAML format. So the reality causes huge pain to our developers. They have to learn all this new concept and cannot really enjoy the consolidation benefits from our infrastructure layer. So these realities also cause pains to our platform builders. They all build capabilities against one Kubernetes platform, but they have no easy way to share their experience or reuse the functionalities built by other platform teams. So now let's look at OAM at high level and to see how OAM can help us to solve these problems. So OAM itself is not that complicated. It's just a standard to write YAML files to define your applications, including the application artifacts, configurations, and its operational requirements. So since OAM only cares about the schema of the YAML files and the relationship between these YAML files, just as Brandon showed, so you can still use your favorite tool to actually generate those YAML files as long as it is compliant with OAM schema. You can still use customized Helm templating or any high-level DSL tool you wish. Also, OAM leave the packaging part out. You still can use your favorite packaging tools like Helm or CNAP to package those OAM-based YAML files. And similarly, you can choose to use GitHub approach to deliver the YAML files to the platform. But to parse and apply the YAML files, we still need an OAM implementation. It is the implementation's job to actually create the resources application needs, deploy the OAM-based application to the platform underneath it, and operate the application continuously. And inside Alibaba, we build a Kubernetes-based OAM implementation. It leverages many capabilities provided by Kubernetes. It also leverages the cloud services and resources provided by Alibaba Cloud. And of course, OAM is a spec itself, so it is platform agnostic. You can switch from Alibaba Cloud to other cloud providers with the Crossplane implementation, and you can even switch from Kubernetes to other infrastructure platforms if you wish. And now we are working on a Crossplane project to open source the OAM implementation furthermore. So it will be much easier if you want to try out OAM or contribute to an OAM implementation. And we hope to build an ecosystem for OAM with help from the Crossplane community. And now let's dig a little bit deeper of OAM. So an OAM application usually have four major parts. The first is a component. It is to define what to run and what cloud services application requires. Second concept is trait. A trait can be attached to components. It is to define the operational behavior for components, for example, a scaling policy or a logging policy. Third, there is a concept called scope. It can be attached to components as traits, but it is used to set group-based policies like a security policy, health checking policy, networking policy for a group of components. And after we are defining those three major parts, the application operators need to do the last part to configure all these three parts with a concept called application configuration. And for each application, you can have multiple copies of application configurations, so you can deploy multiple copies of them to the platform. And here is a more concrete example of OAM-based application. It is a PHP web app. It has two components, a web server and its PHP code, and a Redis server. For the web server, we apply auto-scaling trait for handling burstable workloads and a root trait for routing the HTTP request from external load balancer correctly. And for the Redis server, we want to scale it manually and upgrade with some more careful canary-based approach. And similarly, we can attach a scope to the two components. And the scope we attach here is security group, one public security group for the PHP server because it's need to interact with the external world, and one for the Redis server is a private one because it only need internal communication with the web server. Another benefit OAM brings to the table is the separation of concerns. For example, if you are familiar with Kubernetes, you know that the deployment resource inside Kubernetes have both the pod templating section to define what to run, and also the replication section to define how to run it. So it is kind of all-in-one model that it contains both the developer concerns and the operational concerns. And it is normally fine for a small startup if your developer also manages the operational tasks. But for large companies, Alibaba, it may not be the case. It is very common for large companies to have a dedicated SRE team to ensure the reliability of application, including things like capacity planning, security policy, and auto-scaling. So if we bring the operation automation into the picture, we do need the separation to avoid potential conflict between the human operation and the system operation. So with OAM, we clearly separate the concerns, and we separate the concerns to the different logical resources. For example, the components and traits with well-defined relationships. So the dev team only cares about what to run, and the ops team care about how to run the components. And Kubernetes is also very flexible, extremely extensible. You can define new APIs with customer resource definitions and introduce new behavior with customer controllers. This kind of flexibility is actually also cause issues in reality. First, it is not easy for users of Kubernetes to discover those new APIs and understand their runtime behaviors. Second, there is no standard way to define conflict between those new capabilities. For example, we do not know if two different horizontal pod autoscalers can work well with each other, and we don't even know if HPA can work well with a vertical pod autoscaler. Finally, we don't even know what workload actually supports horizontal pod autoscaler. And thus in OAM, we'll create a system called a trait system. So for each new capability, the creator of it needs to explicitly define not only the API of it, but also its runtime behavior. More concretely, they need to define what workload can the trait apply to, and if there's any other traits that cannot work together with it. So we shift the conflict avoidance responsibility from the developers to the platform builders to ensure a better experience. Also with this system, users can list all supported capabilities within the system with a simple kubectl command. So I believe now you get a motivation of the OAM project. And at Alibaba, we have 4 major goals in mind to build the OAM project. We want to provide the right level of abstraction for the developers to improve their application management experience. We want to make the collaboration between devs, the SRE teams, and the operation automation system simple and reliable. And we want to make the application to define once and run everywhere without any major construction. And we want to make the platform builders' life easier by discovering and reusing well-defined capabilities. And next, I'm going to talk about some of our early experience of OAM inside Alibaba. From technical side, 3 platforms inside Alibaba already supported OAM today. We work with developer productivity team to provide OAM support in our CI/CD system. So the developers can simply submit an OAM-based YAML file to our CI system and then deploy directly to the platforms underneath it. And from the user side, we already have 4 early major adopters. and we got very positive feedback from them. They are excited with the platform agnostic capability and the app abstraction that makes Kubernetes much easier to consume. And the first platform to support OAM is called EDAS. EDAS is a distributed application service on Alibaba public cloud. Its main focus is Java-based microservices. So most of the applications running on EDAS are both distributed and stateless. And like any other traditional PaaS before Kubernetes, EDAS has its own ecosystem, and thus its capabilities could not be extended easily. After adopting OAM, EDAS now exposes developer-friendly abstractions like containerized workload, and at the same time, the whole system could be extended with OAM components and trait systems. For example, EDAS now supports traits like traffic rollouts, autoscaler, and application routing policies, which are actually mostly based on the existing capabilities inside the cloud-native ecosystem. And now EDAS also leverages OAM trait system to manage those capabilities in a much more unified manner for better discoverability. And the operator platform also supports OAM now. The operator platform, it is an internal service for running applications that are operated by customized Kubernetes operators rather than the default controllers. For example, we have messaging queues like Kafka, service discovery system like Zookeeper running on this platform. And most of the applications running on this platform are both distributed and stateful. The stateful application usually needs more complex operational capabilities such as in-place rollout, backup restore capability, and manual scaler. And these capabilities are common for operating stateful apps. But today, those functionalities are re-implemented in many different Kubernetes operators. For example, you could find SAD, Kafka, MySQL operators handle uploading backups to S3 bucket in the almost the same way. And with migration to OAM, now the Alibaba operator platform actually provides those kind of common operational capabilities as traits, and we use them to operate different stateful applications. This saves us a lot of engineering time and makes the system easier to maintain. And the last platform I want to talk about is Alibaba Serverless Platform. It is also a Kubernetes-based platform. It supports Lambda-style function workload, but also supports other workloads such as container and Knative serving. Besides that, the team has spent a lot of effort to build integrations with cloud resources and services. Part of the effort is actually duplicated with EDAS and operator platform I just mentioned above, which are also working on cloud integration. And after the serverless platform adopt OAM, it is able to describe the full application instead of just a single function. And it's also share the same system to consume Alibaba Cloud resources and services as EDAS and operator platform. Moreover, now it uses OAM to describe and manage function, contain, and Knative service in a much unified way, which lower the learning curve for our developers. So by working with these three platforms, we already built tens of common trees and components. They are all reusable and developer-friendly building blocks. This will dramatically reduce the effort of creating any new lightweight platforms. And now each PaaS providers can still provide unique values through the extensible tree systems of OAM. And we are working on open sourcing these building blocks in the Crossplane project this year. We hope to work with the community to make OAM and Crossplane a true ecosystem for making application easier to manage. And on the other side, with the help of OAM, we will continue to consolidate the PaaS experience at Alibaba for our developers. The developers only need to learn one set of key concepts and common capabilities to deploy and operate their apps within Alibaba. It is also easier for developers to know more specific capabilities of specific platforms since the core concept remains the same. We also want to bring this kind of experience to the communities through the Crossplane project. And overall, we see 4 benefits for platform to adopt OAM at Alibaba. So first, it helps them with a modular and standardized design. It brings clear separation for developers and operators. It makes Kubernetes easier to consume, and it unifies the way to consume both the cloud services and the resources from Alibaba Cloud. And for the end user, they will enjoy a consistent application management experience across different platforms, and they will be more willing to adopt new kinds of open paths compared to the traditional private garden filling paths.
So this is a fancy flight tracker demo we're going to show you. It's going to show the flight data and earthquake and map data. So if you click on the flights, you're going to see that the flights actually showing up on the map. So where's the data coming from? It's coming from a database. So that database is going to be the one we're going to talk about today. So Brandon has already walked you through this diagram. So the key piece is that this data API, which talks to a Postgres database. And we're going to provision this database on Alibaba Cloud. And it's not about hybrid cloud. It's really about we can deploy the same database application on different clouds without changing any script. So here are some prep work we're going to do. Actually, the first 3 steps will be basically provisioning the database. And here we're going to be using a provider called Alibaba Provider. So I'm going to check the provider is ready. So yes. And then we go to the third step. If you're trying this at home on your own, you don't have to do the second step because that's just testing your first step. So here we are doing registration and consuming this Crossplane resources. So there are a couple of steps involved, but what Crossplane provides for us is a capability to unite or unify the underlying managed resources on different clouds, right? So the users don't have to do it. What OAM, as Xiang mentioned, the other part of it is traits. The traits will provide you with the abstraction on top of your operational capability and workloads. So together, they provide this unified user experience to the customer. So here we have the Postgres requirement. And that's the one that's actually going to create the database, provision the database. We need to remember that kind name, API name, because we can be using it later. So when Crossplane is provisioning this database for us, we also have the trace that's abstracted by OAM. Together, we have this abstraction, and I really like the way Kelsey put it earlier that Kubernetes is a database, right? So OAM provides a view on top of the database. That's what we do. Now it gets to the part where we actually deploy the application. So first we would install workloads and traits. These are pre-existing because it can be applied to other components as well. So now we're going to add the OAM extension onto the Crossplane controller. So the Crossplane controller can talk to OAM configurations. And here we are starting to define the components. And again, Brandon has showed you this, but remember the name Postgres SQL instance requirement. That's the one we provisioned. And here in the component definition, we don't have any details on the physical database itself, whether it's sitting on Alibaba Cloud or other cloud. We don't say it here. We don't express that here. That's the level of abstraction. So all the other components are the same. They only talk about application related stuff, no operational tasks. And then putting them together, this is called application configuration. And we have components, we have traits. Here we use the mutual scalar trait, putting them together onto each and every component. And then we deploy them. So that's basically the script you're going to use to hook everything together. But like I said, you're not going to change it for different users. Here I'm showing you that we're not cheating. This is actually port forwarding, and this is the local host. I'm not using another place. And here is the database. That's the dashboard from Alibaba Cloud. This is the database we provisioned. And I'm copying this host name because it's going to actually be used in one of the pods. Right? It has to talk to the database. So that data API pod is the one that's going to talk to the database. So we should have seen at least some logs inside it mentioning that host. Right. So let's copy this over. And yes, so we see the host actually is the one that we're using. So that's basically the quick demo of what we use for. And thank you for watching. And I think soon we're going to see the folks from Microsoft doing the same demo without changing a thing, but provisioning the database on Microsoft Azure. Thank you.
Yeah, my name is Artur Souza. I'm a software developer at Microsoft, and I'm going to present the same application running on Azure. So let me pull up my screen here. Give me a second. Okay. So I'm assuming you can see my screen. So in this demo, we're going to go through the same installation process. Actually, we went through that already. So we made sure we have the prerequisites up and running. So Helm version and the kubectl version. So for this demo, the Helm version 3.1.2 and the kubectl version 118.2 and the cluster is 118. We're using minikube installation here, okay? So we went through all the setup that you can see. The link is provided by Nick on the chat room. And we also went through the Azure Provide installation. That's the main difference here. And in the Azure Provide installation, we also had to go through the credential principal provisioning. So that step is important. Make sure you go through that. So as you can see, we do have the Azure provider installed. So after that, we're going to take a look at infrastructure definition. So after we went through all the installation process, we go to the publish infrastructure. And just like for Alibaba, we are checking now if we have the infrastructure defined. So we're going to go through the same process, and we're going to go get infrastructure definition. And there you go. We have that set up already. And in this setup, we also could create compositions, for example, to provision a Postgres SQL database. But in this example, we're just going to skip that part. You can do this at home, but we're going to skip that part to go to the OAM part. So you can go through this step at home. So now we can go to the OAM part where we're going to run the application. So the application is the same application that you saw today, and the same exact binaries, just running a different cloud. And we're going to define all the workload definitions. And not only that, but also all the definitions we need for OAM. So this will tell which type of workload each component can run. So we have a single YAML, and this YAML is the same for every cloud. It's not a special YAML for Azure. This is the same YAML that could be used for Alibaba as well. So as you can see, we created the containerized workloads, manual traits, and PostgreSQL instance. But only the definition, nothing's provisioned yet, okay? So now we go through the components, so you can see. So all these components are the components for the same application. So all of them are defined as single YAML. They are separated here by the separator, as you can see. And we're going to take the same content, as you can see on the screen. We're going to get it from a URL because it's already pre-baked for you. So you can just copy and paste the command. And once you apply, you're now going to have the components defined. Again, not provision yet. It's basically declaring the components. Let's take a look at the components, how they are listed. And yep, as you can see, the same ones that you saw on the YAML file. So they are all containerized workloads except the database, okay, which is a PostgreSQL instance. Now we're going to actually run the application. And that is done through the application configuration in OAM. And this configuration tells OAM how can I run this particular application with all the traits and parameters. So we're going to apply that file now. And the same file again that was used for Alibaba. There's nothing special on this for Azure. Only the provider part is different. So now let's describe the application configuration, so we can get into more details. You're gonna see now all the components that we were in the YAML, they are here now in Kubernetes. And this time, Crossplane is behind the scenes trying to provision all the components for us. And it knows how to provision to the right cloud. In this case, we used Azure. So next step, let's take a look at the resource group. This is a key part on Azure because all the resources in Azure belongs to a resource group. So, and the resource group here was provisioned by Crossplane, and the naming also implies that. It's a name generated by Crossplane. So let's refresh here, just make sure you got the time to provision. Okay, so you could see it. And now we click on that, and you can see the resource group there. And guess what? The database is also provisioned. Okay, so it is a managed database, and we're going to use this cloud, this cluster, Kubernetes cluster. As you can see, the pods are also running in the default namespace. If you just pay attention to the default namespace, that has data API, flights API, Quakes API, weather API, and web UI. So these are the containers needed for this app. And it's going to talk to a managed database on Azure. Since we're using Minikube, we're going to go with a port forward. If you're using this on AKS, you could use the load balancer IP address. But for Minikube, we're going to use port forward. Okay, it's listening to port. So let's now take a refresh, and we see the same app, and just in a smaller screen. And now we're refreshing the data. So it's loading all the data into the managed database on Azure. And next, let's check the data is there. So the flights API, yep, we see the flights there. Next, we're going to see earthquake data. So earthquakes. And last but not least, we're going to see the weather data. Okay, so everything was loaded, the same app, just in a different cloud. Okay, and thank you very much. That was my demo.